Bismillah wa salatu wassalam ala Rasulillah. My name Assistant Prof. Yousif Ismail Al Mashhadany. I am lecturer in University of Anbar, College of Engineering, Department of Electrical Engineering. I have BSc in Electrical Engineering from University of Technology in Baghdad in 1995, and then MSc in Control Engineering in 1999 from the same university, and then a PhD in 2009 in Electrical Engineering with specialized biomedical engineering from the same university. After that, I get postdoctorate fellow research from University Malaya from UMBDAC Center with biomedical engineering. I have 39 published papers with Clarivate journals and Scopus journal index. I have 34 conferences. My interested with control systems, robotic, intelligent system, and solar energy. In this conference, I submit a paper with a title Optimization Practical SCARA Robot Trajectory based on a Linear Quadratic Controller. A SCARA Robot, we know, is the abbreviation of Selective Compliance Assembly Robot Arm. This robot first applied by Nidec company in Japan in 1981. And this robot, we know, has three main rotating joint: shoulder, elbow, and wrist joint. The wrist joint work with the gripper in a vertical plane. And this robot has many applications in industrial and biomedical application. In this work, will apply the linear quadratic Gaussian controller models for controlling of the trajectory of a robot. The linear quadratic Gaussian controller has many specifications for get the optimal trajectory, because the mean power point for this instructing in this robot is the collecting of the controlling by collect the instructor for plant with state feedback gain and adjustment the error signal. This paper used the virtual reality model for SCARA robot, and this model built according to the real parameter setting for a robot, such as the speed of a robot, the dimension of the main robot, and like that. The test of the simulation get the high accuracy result with a specific real limitation. Therefore, this design has a reliability for implement robot as the practical robot with different application. A basic principle of linear quadratic Gaussian optimal control, we know the linear dynamic system can describe by mathematical model. The mathematical model present for the any physics system very important for the prepare of control system, because the first step for building the practical controller is the mathematical model for simulation. Therefore, the linear quadratic Gauss theory depend on the steady space mathematical model. The steady space mathematical model depend on the two equations. The first one is the status equation. The second is the output equation. We know this system has four main matrix. A matrix is the characteristic matrix, B matrix is the input matrix, C matrix is the output matrix, and D is the matrix for MIMO system. Also, linear quadratic form control has prepared for control signal U. This described by this equation U equal minus kx. X is the status of the system, the number of status equal to the order of the system. K is the state feedback gain. This matrix will calculate with accurate form to minimize the quadratic cost function. The weight matrix, the general quadratic cost function, can describe by the equation 3. This equation, the mean equation for prepare the control signal for a robot. Therefore, consists from the summation of the K matrix. This K matrix is the state feedback gain matrix with status and with input and with the disturbance input, and collect all information for the optimal controller. The configuration of the linear quadratic Gaussian system consists from two main parts. The first part is the linear quadratic Gaussian controller. This B matrix, K sub G, the Kalman gain. This gain very important for controlling to get the optimal result with the steady state, and this term for prepare the state feedback gain matrix with the mean A matrix is the characteristic matrix, and after the combination will get U signal. This the output of the controller to send this signal to the robot. The second part of the system is the SCARA robot system. This robot we know described by the mathematical model set of the differential equation, and will use the kinematics equation and the dynamic equation to describe the trajectory of the robot. This slide describes the SCARA robot form of robot. The structure of the robot: base and mean joint is three main joint. The first shoulder joint rotating with 360 degree, and a second joint, elbow joint. This joint same shoulder joint rotating with 360 degree, and third joint has vertical movement, and we can adjust this length with the suitable application to the suitable application. And the fourth joint for the gripper, and this joint in practical system described by the sensor integrated grippers and ultrasonic sensor for capturing of the things. Also, this gripper has capacitive and inductive approximate sensor can used. Also, force torque sensor. All this sensor can used in the gripper according to the application can be used. Also, can use the vacuum gripper, very important with many application. Now explain the robot kinematics. We know that the H parameters, these parameters describe the kinematics and how solve the inverse kinematics to get the angle of joint to make the posture of robot with the final form to arrive the target with the optimal trajectory. In this structure, we have four main joint, and we have 4 theta. One is 0 because this vertical joint don't has rotating, therefore no angle, but has displacement. This angle and displacement, because this for a gripper and this for shoulder joint and elbow joint. This L the length of forearm of joint. Therefore, the transformation matrix from the 1 to 0 is the A1 for the shoulder joint, consists from this according to the Euler form, and then with the second joint, and this for third. Therefore, this just for this parameters D3, and for from 4 to 0 is the combination with the L and D3 and D4, L1 and L2, and all this. The inverse kinematics solution for this robot by serial multiplication of the transformation matrix A1 to A4 to get the overall transformation matrix from to 0 position. And then when I need the transformation matrix for the end effector, we can get by take the inverse matrix of the first three joint with the multiplication by the transformation matrix from the H to R to get this transformation matrix for TH to R. This for the target position X, Y, Z. Now, this the multiplication to by solving the matrix operation, we can get final form of the theta 1 and theta 2 and the D3 and the theta 4. Therefore, now we solve the velocity. This used for velocity equation by using the grammar rule for solving, and we now by use this equation we can make simulation by the prepare of the suitable instruction for the joint and implement the optimal trajectory according to the performance index of the linear quadratic form. The design of the application of SCARA Robot in this paper by virtual reality model. We know the virtual reality environment is the design software within MATLAB to get the 3D dimension for application. We used this environment to build all this lab, this such SCARA Robot lab we can consider, because it has all can done all application for MATLAB movement of the SCARA robot, and can make many application. Just change the environment, or can make a biomedical application, industrial application. Now this environment for industrial environment, this used for control of product of factory, because now this for serial product. Now we select the damage product and transfer this product to another path. This the mean path of the product of the factory, and the SCARA robot will get the order for select the limited sample, because this sample is the damage sample, not correct sample for product. Therefore, will transfer to this. This summarized for the jobs will done by this robot. This design built according to the mean physical quantity for the SCARA robot, the dimension, the velocity, the weight all the parameter is the real practical. The steps of the design has three main steps. The first step is the design of the environment lab. The environment, I mean by the environment, is the envelope of the robot. And now in this envelope, we have two paths. The first path is the product path, and the second is the path for the damaged product. This product will transfer by robot from this path to this. In the first time, I make this design by the virtual reality, and then make testing for this, make test of the simulation for the environment lab to explain the movement of the product with this path. We see this a product will transfer from this side to this side. The main job for the robot is the select the damage sample from this side to this side by the instruction we'll get from the controller, such as micro process or microcontroller or PLC, according to the technique used by the application. Many times used microcontroller or PLC to implement this application. After that, the second step is the design of the SCARA robot and prepare prepare the environment for the design of the robot. The robot consists from the design the base with this form, and then the first joint, shoulder joint, and elbow joint, and then the third joint and the gripper. This designed by the virtual reality, and the control designed by using a linear quadratic controller to get the optimal trajectory and the order calculate here and transfer to the robot. And now we'll make the test simulation. This is the environment called by Simulink, and the instructor will prepare by Simulink and transfer to this form. This explain the trajectory of the robot. Now this general trajectory moving 360-degree. This the rotation, and the second joint is the rotation, and the third joint is has vertical movement, and the gripper for capturing and release the damaged product. This is the top view of the movement of the robot, and we make control for speed of the robot. The mean target is the accuracy of the robot is very high, and we see this in the final form of the trajectory. This with many view. I make design with the 5 view, orthogonal view, and top view, and left side view, and front view, and right side view to describe the model with the 3D form with optimal configuration. Now the final form of the final step for the design is the overall design. This is the overall design SCARA robot system based on linear quadratic controller. Now this for prepare of the environment for the two path, and this for prepare this for the design of robot by using linear quadratic Gaussian controller to get the optimal trajectory. After the prepare of the instruction for the robot, we'll get three mean output. The first one for the shoulder joint, and the second for the elbow joint, and this for third joint, and a gripper in the same time. And now added one term for the environment is the for the selective box. This is the damage product, and this the same mean 5 transfer product. And now we can test this environment by using MATLAB Simulink. I used MATLAB version 2019 version B. This the call of the model from the virtual reality environment by using MATLAB and make the test. Now this robot selective the damage product, this, and transfer to the second path. This is the top view for selective. We can see optimal trajectory and very accurate design for the SCARA robot, and I can implement this design with any environment such as biomedical environment or industrial environment, and also can modify this control with another form. Therefore, I will explain this in the conclusion. Also, we can see the very accuracy for selective and waiting for the second order and transfer the sampling with high accuracy form, because this application such as industrial application or biomedical application did the very accurate design. By this work, I get high accuracy for design, and we can implement as a practical model. At the final, the conclusion for this work, the using of the linear quadratic controller has a very accurate result, and we can get optimal trajectory, and this optimal trajectory can done with industrial robot application or biomedical application or any type of application we need. Also test the result has suitable speed and suitable estimation of location and optimal control law, because the output has acceptable value for the time response with the steady state and with the transient, because when the test of the classical test control, such as the maximum overshoot and settling time and rising time, this is very acceptable value. Therefore, we can consider this robot, we can consider this design as the reliable design, and can implement this design as the practical design. Therefore, I can implement this design as the practical design, and I can make cooperation with any research you like work with this field, or any university you need to implement this design as the lab implement or practical implement, because this design can used with the study of the robot, such as mechatronic lab or robotic lab or industrial application lab. Therefore, anybody need cooperation with me, we can contact with me by details, by email or by phone that explain in the slide. I am very happy to explain my work with this conference. Thank you very much for, and I hope meet you with another conference. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.